Hello everyone. We are going to start with the builder design pattern now. The builder design pattern is one of the most important design patterns, I would say, because it is very highly used in the design questions. So it is uh, a creational design pattern which lets you construct the object step by step. But the main purpose of using the builder design pattern is to achieve the layered architecture so that you can distribute the purpose of every class separately. So for that, builder design pattern is majorly used. So let us see how we are going to make it. Then I'll also come up with some of the examples how interviewer is expecting you to use the builder design pattern in some of the interview questions. Like say if the interviewer asks you to make a download manager, let us say, and in terms of a library, you want a download manager library, then how would you approach that? So in those cases, builder design pattern is one of the most important ones. So let us go through the code. We'll try to simulate the builder design pattern now. I'll create a class. I'll create a file, builder.cpp. Hash include iostream using namespace std. Now we are going to take a simple example of a car class and we'll try to have a builder inside it through which we can create the car object step by step, and we will understand how it is useful. So let us say I have a class car, and inside car class I would be having certain members. So I'll make them private, int seat, let us say, and we will be having a string for engine. Then I would also consider, let us say it has a GPS. Let's keep it simple for now. These three are the uh, major attributes of the class. Now we also need some functions which can expose, sorry, we'll remove it, which can expose the members of the class, right? So we need some getters. We are not going to make setters because that is the main objective of the builder. So I'm just going to define the getters. So we have int get seats, let us say. We'll define it. Now we need a string get engine, let us say, and we also need a boolean get has GPS, right? All these functions are very simple. So for now, you can leave it as it is. We'll come up with the definition afterwards. Now, I would say we need a builder class which can actually set my members, right? So how am I going to do it? Let us say we make an inner class called builder. So inside this inner class, I would require certain setters. So if I'm going to make setters, then I would also require these same instances inside, like seed, engine, and hash GPS are also required inside the builder. So I'll again make it. Let us say we have int seed, string engine, then we have boolean hash GPS. Now, what are going to be the public members of this class? The first public member would be the builder. I need a builder constructor. Inside the constructor, I'm going to set some default values. They are just default values. So the seat is going to be inside the initializer list, I'm going to set the seeds to 0. Engine will be set to unknown, and let us say the has GPS is also going to be set as false. Right. So we have assigned some default values to it. Now we need the setters. So what return type will my setter have? So the point is, every time we are going to call the setter, I'm going to return the same builder instance only. The only function which will return the car instance will be the build method, right? So let us try to code it up and you will understand it better. So like I said, I'll just return a builder reference and I'll create a set seeds method which will take int seeds, let us say, and in this you can do this seed will be equal to seeds, right? Now what do you have to return? You can return by dereferencing the this operator, right? Because you need to return the reference of the builder. So the current object's reference you have to return. So this is the pointer. So you can dereference it and return it as it is. Now, in the same way, you need to have other methods, other setters basically. Set engine, and you can have string engine coming as an argument. And here you would say engine will be equal to engine and return the dereferenced this. In the same way, builder set GPS, and you need a boolean has GPS. This has GPS will be equal to has GPS, and you return star this. Right. Till now, everything is simple. Like you're going to call has seat and you will pass some seat. It will return you the builder reference. Over that, you can call the set engine again and return the same builder reference again. And over, you can call these three functions simultaneously, successively, basically. Now, you need a function which can at the end give you the car object. So for that, you need a car pointer, a function which returns the car pointer. We'll name it build. And what it does is it returns a new car object, right? And it will take the seats, it will take the engine and the hash GPS that you have set in the builder class, right? Now we are getting an error. We'll see why we are getting this error. First of all, let us move up and we'll just complete these functions, which is return seats. We have here return engine and we have here return hash GPS, right? So the getters are done. But the point here is why I'm getting an error over here is that the inner class cannot directly call the outer class. We need a constructor right now, right? So if we have the constructor, then we can call it for the class object. So what I'll do is I'll just say that car and it will take int seats, comma, string engine, comma, boolean hash GPS. Again, using the initializer list, I'll just say seats of seats, comma, engine of engine, comma, hash GPS, hash GPS. Right. So now you have a private constructor. So let us see now the since it was parameterized constructor. So we are done with this, and we have the uh, the error is removed now. So let us see how we are going to use it. In some of the examples, you would also see that people also create some class called directive classes, I think. That is something which interviewer is not expecting a lot. because that is a standard class which is going to create a default object and all. So that is not of much use at this point of time. You require the builder pattern because you have segregated the setters. Basically, if you can see here, you have created an inner class which is going to take all the arguments and it will keep it with it until you are going to create the car object. Once you create the car object, oh, after that you will be using the same object further. So you must be thinking, how is it a layered architecture? Let us say at this point of time, your car is a download manager that has some attributes inside it. Now, the builder is actually a request that the user wants to give, which is something like, I want to give a URL to my download manager. So my builder is a request which will take the URL. It can also take some arguments like time, or it may have notification related arguments we can take. And after the request is done, you need to submit it to some other class, because after taking the arguments, the class which is going to download it is a completely separate entity, because it has to establish a connection and all of those steps will be taken care of. So you will keep them inside a separate class. So now you can see that we have gone to a layered architecture. In that case, you will be having an attribute. You can have an attribute like a dispatcher, download dispatcher, which will take a request as the argument and you can pass it over and then it will go on. We will come to this example and we will see how to code the download manager in some later video. First of all, let us complete this one. So at this point, we need a semicolon over here. Now we just need int main, and we can have a car pointer. Let us say car, which is now car. Inside that, you have a builder class, which you're going to access. Now you have the builder instance. Over that, you can call set seat. Let us say we have 4 seats. Then we have dot set engine, and you set it to ports, right? Then you have set GPS, and let us say you don't need a GPS inside that sports car. And at the end, you are going to call the build method because it is going to return you the car pointer. After this, you can actually use your car object and you can perform any task over here. Let us say you may be having a function called drive. So that drive function can be called from the car object now. So this is the main point of using the builder pattern. Let us try to run this and we'll see if we encounter any error. G++ builder.cpp. We'll name it builder, or let us say build, and let us try to run it. And it compiled successfully, and you can see there's no error we have encountered. And we will be using these design patterns later in some video. I'll be explaining how we can use it in the design questions which are frequently asked in the interviews.